All right, so let's go on page 85, and we're done. Okay, so, and we're using the bearing stuff that we talked about yesterday. It'll be said both ways that we talked about. You can't draw a teeny tiny picture. It doesn't have to be beautiful. This isn't an art class, but you got to draw it to where you can label it and you can figure things out, okay? So this says, 2 ships leave a port at 8 a.m. Ships A sails with a bearing of north 68 degrees east at a speed of 17 miles per hour. Ship B sails with a bearing of south 35 degrees east at a speed of 12 miles per hour. If the ships maintain their paths, how far apart are they at 2 p.m.? Okay. So the ships are going to start from the same place. If you were going to measure a bearing from wherever you're measuring a bearing from, you want to draw a little north, south, east, west type of thing there. Just a little tiny like dotted line type of thing so that you can wrap your mind around what's going on here and what the angles are. We're going to sail with a bearing of north 68 degrees east. So that means we go north and then we swing out 68 degrees east, which should look something like that. And that means that this piece right here is 68 degrees. And if I didn't have my little blue dotted lines there, I wouldn't have anywhere to mark that angle. Okay, everybody with me on that angle? Does it make sense why it is what it is? Okay, so this is ship A. Okay, and then we have ship B that's going to sail with a bearing of south 35 degrees east. So it's going to come this way, south 35 degrees east. This is 35 degrees. Okay. Stop me if you don't understand why I drew something or what's going on with that. Everybody good so far? And this is ship B. Okay. So it tells us that ship A had a speed of 17 miles per hour. That's not a distance, that's a speed. And then ship B, 12 miles per hour. And in the end, it says it's going to maintain their paths. How far are they? How far apart are they at 2 p.m.? So we're looking for how far apart they are. Everybody good so far? All right, so I don't even know how far ship A is from the port yet. Like this is the port where we started. So how do I figure out how far ship A has sailed? I know how fast it went. What else do if I know how fast something is going, what else do I need to know how far it went? The time. So how much time has passed? We started at 8 a.m., right? 9, 10, 11, 12, 1, 2, 6 hours. So if I sail at 17 miles per hour for 6 hours, how do I figure out how far I went? 17 times 6. You got a calculator. What is that? 102. So I've got 102 miles. Then ship B, it's still been 6 hours at 12 miles per hour. How far is that? 72. Okay. So now I have 2 side links looking for a third. I have some angle measures, but none of them are the measures of the angles inside of the triangle, so I have to find at least one of those. Do I have enough information to do that? Yes. What is one way I can find an angle measure? Okay, add 2 angles, subtract from 180. That totally works because this is a line, so this is 180 degrees. So if I add the 2, subtract from 180, I get this angle. And what would that give me? 77 degrees. Good. So that is totally fine. Absolutely nothing wrong with that. Tell me another way to get that angle measure. Anybody see a different way? Not that there's anything wrong with that one, but I want you to see both ways because sometimes one is better than the other. In this case, absolutely not. It doesn't matter either way. But what we do know, if we think of these as quadrants, that this first quadrant is 90 degrees, right? So I can take 90 minus 68. That gives me 22 right here. And then 90 minus 35, that's going to give me 55 right here. And then when I add those 2 together, I get 77. Okay, so it's the same thing either way, but it's whatever makes the most sense to you. It's totally fine. Okay, so now this is the only information that I can find right now without doing some trig or some other stuff. I have to decide if I'm going to use law of sines or law of cosines. And what do you think here? Cosines, okay. And remember, if you're not sure, you pick one and see if you have enough information to figure it out. And then if you do, that's great. If not, it's the other one. So if we're thinking cosines, all right, so if I'm looking for a side length, that goes on the outside. I have to have two other sides that I can square and add together. That's good. And then I have to have the angle across from the side I'm looking for. I've got all that, so that sounds good to me. So let's do law of cosines. I've got x squared equals, take the other two sides, square them and add them together. So 102 squared plus 72 squared minus 2 times 102 times 72 times the cosine of 77. All right. Then we just take the square root and figure out what we get. 110.833. Now, because these are application questions, we're going to write out more than, because again, it didn't ask us what x is. We need to explain our answers, because we've talked about when you take AP Stats, you're going to have to explain maybe kind of in a paragraph way. And if you take AP Calculus, you're going to have to explain in some words. It's not as paragraphy as Stats is, but you got to make sure that you say the right things in the right ways. You have to make sure that you're not using things, you're not saying things like they and it. You can't use those pronouns. Like, you got to say what you actually are talking about and make sure you have all the pieces. So in this case, we would say, so it says, if the ships mate, how far apart are they? So I can't say they are. I would say something like ships A and B are 110.833 miles apart at 2 p.m. So a lot of times our explanations will have, like, we have a subject, we have what we're actually looking for, and then usually some sort of time aspect. All of what ours are, we won't have a time aspect in all of these questions, but and in calculus, it's more of an interval, like from 0 to 2 or something like that. That doesn't really apply to these, but we have to, again, make sure we're using the right words. You wouldn't always have to have it worded exactly like mine is, but we'd have to have all the right pieces in there. Okay. What questions do we have? Anything? Okay, so I'm not so worried about this part, because you should have this part down, but if you don't get this drawn and labeled correctly, you're not going to be able to fill in the right numbers. So drawing the picture is the main focus of what we're doing today. All right, let's look at number 2. We have Bruno and Aliana. They're figure skaters. They're starting from the same location. Bruno skates 29 feet on a bearing of south, 55 degrees, 9 minutes west. Aliana skates 18 feet at a bearing of south, 16 degrees, 51 minutes east. How far is Bruno from Aliana? All right, so I want to kind of have an idea of where to start so that I don't draw my picture in my question. If I start here, Bruno's going south and west. She's going south and, south and west is that way. South and east, so they kind of started somewhere up here I'd say like at the top. Okay, so I think I'm going to start there. Since I'm starting here, here's my little north, south, east, west. Whoever's phone that is, turn that off, good Lord. Starting from so Bruno skates 29 feet. We're going to go south and then west about 50 degrees, so something like this. That's 29 feet, and that's Bruno. Aliana's going to go south 16 degrees east, which is like this, about 18 feet. And that's Aliana. Okay. And I didn't put the little angles in there because they're in degrees and minutes, and I want to fix that first. So if I have 55 degrees, 9 minutes, that's going to be 55 plus 9 over 60. So I want to figure out what the decimal is before I label my picture. I think that would be helpful. And what does that give you? 55.15. So if he went south and then west, that means this angle right here is 55.15. And then she went 16 degrees, 51 minutes, so that's 16 plus 50. Oh my gosh. See, I told you, my brain is just not. 51 over 60. There we go. That gives you 16.85. Agree with that? So that's what this angle is here, 16.85. I'm just labeling them on the outside because there's not a whole lot of room on the inside of that triangle. And I want to know how far apart they are, so that's my x. I need this angle. What is that angle? How do I find it? Add those two together. When you add them together, what do you get? 72 degrees. So now would we use law of sines or law of cosines? Cosines. This is set up just like that other one, right? I have two sides in the included angle, so that helps me there. So that means I'm going to get x squared equals 29 squared plus 18 squared. You go ahead and finish this up and find your answer. The answer would look something like that. What questions do you have? Anything? Okay. All right, so let's look at number 3. Helicopter spots 2 landing pads below. The straight line distances from the helicopter to the pads is 14 miles to landing pad A, 8 miles to landing pad B. If they're 20 miles apart, find the angle of depression. Okay, so we're going to need angle of depression. A little bit of a review from geometry. Have to know what an angle of depression is. We'll talk about that when we get there. But you also have to know if you have 2 parallel lines cut by a transversal, how your angles are related, right? You have different types of angle pairs. You have vertical angles. You have same-side interior angles. And you have alternate interior angles. Alternate interior angles come up a lot. What do you know about alternate interior angles? They're the same. They're congruent. And that's when you have 2 parallel lines cut by a transversal. Okay? All right, so now when I decide where to start with this one to label it, I have a helicopter. It's in the air looking down, so I'm pretty sure I can start up here and then have something. So here's my helicopter. Spots 2 landing pads, right? And we have landing pad A, landing pad B. We don't know which is which on which side, but it doesn't matter. Are you with me? Doesn't matter which side it's on, because if I put them on the wrong side, then I could just think I could walk around and be on the other side of it. So then draw these. Here's landing pad A, here's landing pad B. And they are 20 miles apart. Okay. And we know that, okay, so then we have straight line distances. So let's talk about the different kinds of distances that can be written in these problems. If I'm standing here and I'm looking down at that trash can, so like the straight line distance would be like if I had like laser beams for eyes, that would be my straight line distance, almost like a hypotenuse. The ground distance would be the distance literally from the ground from where my eyes are to the trash can. So you see the differences there? So you've got the ground distance, which is like a horizontal distance, and then a straight line distance, which would be more like a hypotenuse situation. So straight line distances, let's see, 14 miles, so this is my helicopter. 14 miles to landing pad A, 8 miles to landing pad B. and they're 20 miles apart. And then it's asking me for the angle of depression. So the angle of depression, an angle of elevation and depression all come from horizontals. So an angle of elevation would be like from A to the helicopter, I look straight ahead, then I look up. That's your angle of elevation. The angle of depression from the helicopter to landing pad B, this helicopter looks straight ahead and then looks down. That's your angle of depression. Okay? If you label it in the wrong place, you get the wrong answer. Now, this angle, I don't know why that mark is there. This angle here is not inside of my triangle. What angle is that congruent to? Think about what we literally just talked about over there. You got two parallel lines cut by a transversal. Boom. What is that angle of depression congruent to? Angle B. Boom. So if I can find angle B, that is the angle of depression from the helicopter to landing pad B. Okay? Basic geometry skills. Super basic. So I need angle B. I have three sides and I'm looking for an angle. Law of sines or law of cosines? Cosine. If I'm using law of sines, I have to know at least one angle, right? Because I'd have to use it twice. Here, I don't know any angles, and that's fine, because I can have that one from law of cosine. So the side across from the angle that I'm looking for, that's what goes on the outside of my little equation. So I'm going to have 14 squared equals, and then the other two squared and added together, 8 squared plus 20 squared minus 2 times 8 times 20 times the cosine of angle B. Okay. So if you've been doing your assignments like you're supposed to and you know what's going on, you should be able to solve for the angle. Go forth and do that. So then you should get that the angle of depression from the helicopter to landing pad B is 33.123 degrees. And when you're figuring out what to write, you're usually just reframing the question. Just make sure you use the words that are being used and you're fine. Any questions at all? All right. So then the distance, all right, let's look at number 4 if you don't have any questions. So we have Cincinnati, Ohio. It's 540 miles due east of Kansas City, Missouri. So due east means that we know it's going to be a horizontal distance. That's important. So they are, one is due east of the other, and they are 540 miles apart. You have to be able to read the question correctly and understand which one's on the left and which one's on the right. What would be on the left, Cincinnati or Kansas City? Cincinnati, Ohio is 540 miles due east of Kansas City. So if Cincinnati is east of Kansas City, which one is on the left? Kansas City. Here's Kansas City. To the east of it is Cincinnati. You don't have to know geography. You have to be able to read the question. Okay. The bearing from Kansas City to Nashville. So I'm starting at Kansas City. So I'm going to use a bearing from there. So I put my little crosshairs. I'm going to go south 64 degrees east. So something like that. And this is 64 degrees. Even if it's not very accurate, because my picture looks like 45 degrees, but it's fine. And then the bearing from Cincinnati to Nashville. So I've got a bearing starting from here, so I need my little crosshairs here as well. South, 29 degrees west. So this is 29 degrees, and this is Nashville. All right, so before I even worry about what they're actually asking me for, I have some angle measures, but I don't have any angle measures in my triangle. But I have enough information to figure them out, right? What would this angle, what would angle K be? Or how do I find it? 90 by the 64, right? So this will give me 26 degrees. To figure out angle C, that's going to be 90 minus 29, which is 61. We're all good with that? All right, and I'm looking for, so then it says find the distance from Kansas City to Nashville. So we'll call this X. Can I use law of cosines here? No, law of cosines, I have to know at least two sides because that's what goes inside of it, right? So not law of cosines, which means it's going to be law of sines. And so I'm looking for X, that's across from 61. So I'll have the sine of 61 over X equals, the other side length I know is 540. It's across from angle N. I don't know what that is, but can I find it? Yes. 26 plus 61, subtract from 180, and I get 93. Good. So then I can do the sine of 93 over 540. Okay, so that means that X is equal to 540 times the sine of 61 over the sine of 93. So the distance from Kansas City to Nashville is 472.943 miles. Any questions on that? Again, the solving part, even the setting up, hopefully that, I mean, that's what we've been doing, but you got to get the pictures drawn right. So that's what we got to make sure we understand. Okay, on B, we're not going to solve it. We're just going to set it up. It says to find the distance from Cincinnati to Nashville. So Cincinnati to Nashville, so I'll call that Y. Can I find that length by doing Pythagorean theorem? No, why? Because it's not a right triangle, exactly. So we don't even go down that road. Instead, I can just do law of sines again, right? Y is across from 26 degrees, so I can do the sine of 26 over Y, and then use the same second triangle, which is the sine of 93 over 540. And then if you can set it up, you can solve it, but we're not going to spend time on that. I'd rather spend time on doing this last one. All right, so we have a ship sails 50 miles at a bearing of 20 degrees. then 30 miles farther on a bearing of 80. So this time it just says bearing of 20 and bearing of 80, no south, north stuff. So where do we start from? True north, right? And we go which way? Clockwise, right? All right, so if I have a ship, it's going to go 50 miles on a bearing of 20 degrees and then 30 miles on a bearing of 80 degrees. That means I'm going to kind of keep going up, so I think I'll start down here. Start right here, so I'll have my little crosshairs. So bearing of 20 degrees. I start at north and I swing out about 20 degrees. Looks something like that. So this right here is 20 degrees. And I go, that is 50 miles. Then I'm going to go farther. So from here, I need another little crosshairs because I have a separate bearing, and that starts here. Bearing of 80 degrees. So I start at true north, swing out 80 degrees. I would make this 80 degrees here, and this is 30 miles. And then find the distance the ship is from the starting point. So we're looking for that distance right here. Right? Because the ship started here, went here, and turned, ended up here. How far is it from the starting point? Okay. So I have two sides. I'm looking for the third. And I don't have any angles labeled yet inside. If I can get the angle that's across from x, then I can use law of cosines, and that's the only angle I need. So I've got to see if I have enough information for that. Well, I know that if this is 80, how much is this right here? 10. So this is 10. And I know that this is 90, right? Then I would need this angle here. What do we think that angle right there is? I heard 20 and I heard 70. Who wants to defend their answer? Why 20? Alternate interior angles. Look at this. Two parallel lines cut by a transversal. This is 20 degrees. This is 20 degrees. Alternate interior angles again. Okay? So this is 20 right here. Very good. So this whole angle then is how much? 120. So this is 120 degrees. And the first time I said, oh, because I knew it was alternate interior angles, and when I drew it the first time, just FYI, so that you don't get confused on this stuff, I said, well, oops, well, that's kind of thick. I said, oh, well, we have two parallel lines. No, that's not thick enough. Good Lord. Let's not be cooperative. Okay. Two parallel lines cut by a transversal. When I did that, I was like, oh, that's not even using the right lines. It's these. So you could have either set. Just think about what you learned in geometry, or what you should have learned, what you were taught. Let's put it that way. If you didn't learn it, I don't know what to tell you. All right, so this is not Pythagorean theorem. This is law of cosines again. So x squared equals, and then you should be able to finish the rest of that out. What is different about this answer than all the other answers? It's exact. It's a whole number, right? Which, at first, did that seem weird? Probably, because we didn't, we're doing the trig and everything. But I want you to think about why, and you don't have to overanalyze an answer when you do this, but I want you to understand why it is what it is. So let's just think about, if we're talking theta, right, and we're starting from here at 0, that this right here, 120 degrees is somewhere over here, right? So if this is 120 degrees, what is the reference angle for 120? 60, right? Does that make sense? Your reference angle is 60. What is 60 degrees in radians? Pi thirds, right? What's the cosine of pi thirds? 1/2, because some of our trig values, when we use our special angles, they come out pretty. And since essentially this number right here is 1/2, then when we took the square root of all that, it happened to come out nicely. Even if this was 1/2, maybe the square root wouldn't have come out nicely, but that's why you got a nice pretty number. Because every now and then you get a trig value that's decent, right? And in this case, that's what happened. All right, any questions? When I give you your assignment, you are going to skip 1 and 2 for right now. You're not omitting them. You are skipping them. You're going to work on the rest, and then on Tuesday, we're going to work 1 and 2 together. All right? You could probably get them drawn, especially number 2, but I want to work through them because a couple of other things happen that I want you to be able to think through, but I don't want you just stuck on those and not able to get anything else done.